Good morning, everybody. So I believe we are live. Krista is in the back room. She'll give me inputs as to how the program is going. And I would like to introduce the topic now, 4IR Factory of the Future, a case study on how digital transformation accelerated time to market in the production of ventilators. So this case study takes the audience, you listeners and viewers, through a journey in which a multidisciplinary, multi-organizational South African team was able to design, develop, and produce ventilators needed amidst the COVID-19 pandemic. And this was done within 3 months from design to start of production, and the production of 10,000 ventilators was completed 3 months later. The program today will highlight how digital transformation using digital lifecycle software has accelerated the product development process. And later on, how it was used to create a virtual factory consisting of multiple private companies, who we will introduce in a moment. It will also touch base on how digital twins were used to accelerate the production lines and optimized to the design of the ventilator, because you can imagine this was a rapid design and rapid production process. So the only way it was possible was through full digital processing. So without much further ado, I'll go through the team that is present here. And I'd like to start with Chief Executive Officer of Quali Health, Dr. Nthabiseng Legoete. And Nthabiseng, could you please introduce yourself and just say a few words about your role in the project?
Sure. I'm Nthabiseng Legoete. I'm CEO of Quali Health, and our role in the project has been a contact center support or a quality support, or monitoring not only the quality of the ventilators in terms of just the feedback that we've been getting on the ground, but also giving technical and medical support to the users of the ventilators. So we've done it via WhatsApp platform, which in the pilot phase was very efficient, and we'll obviously gain more insights as time goes on.
Thank you. I'd like to move on to Mr. Peter Brearley, Operations Director, Care Medical and Healthcare. Peter, if you could say a few words, please.
Certainly, thank you, Martin. Thank you for the opportunity to be part of the panel today. We became involved with the assembly of the life CPAP units and the associated breathing circuits. I think because we've been involved with the CSIR, and we have a relationship through our diagnostics business with the CSIR, but also obviously as a well-established manufacturer and assembler of medical devices, we had all the necessary accreditations and so on to do this, or pick it up quite quickly. So I think that we've been able to respond adequately to the demands, and they certainly haven't been easy because of the short time frames, particularly long supply chain lead times and so on. So it has been a challenge, I would say that, but I think that all of us together as a team, the CSIR and the other manufacturers who supplied components, I think everybody's responded pretty well to the challenges that have been presented to us.
Thank you, Peter. I'd like to move on to Mr. Kobus Oosthuizen, Country Manager and Chief Executive Officer, Siemens Industries, Software Division, Africa and Middle East. Kobus.
Thank you, Martin, and thank you for everybody for this opportunity. I think just from our side, we supplied basically the technology platform that was used for the digitalization and pulling all of this together in the Industry 4.0 initiative. I think from our side, it's been quite great to be part of this project. The support that we've had with the CSIR, we've had a long-standing relationship with the CSIR in the PLM space, and this project gave us the opportunity to expand also in the production space to show how rapid development or rapid scaling can be achieved by using digital technologies. So thanks a lot for that.
Thank you, Kobus. And then I'd like to move on to Mr. Johan de Tooy, Chief Executive Officer of Samera.
Thank you, Martin, and thank you for the introduction. And for the CSIR to allow CIMERA to participate with the National Ventilator Program, it truly gave us an opportunity to live out our mantra, which is engineering a smarter tomorrow. My team really enjoyed the positive spirit of collaboration amongst your team members. It was quite inspiring in this challenging year to see how South Africa come together and no task is too big. Then equally, a big thank you to you, Kobus and Siemens, for making the resources available and allowing your expert team to blend into our team and the CSIR team as one, bringing more know-how and the resources to the table. It was a big enabler. Then in a way, CIMERA's experience in the past 10 years since our founding in 2010 prepared us well for this task. To establish a digitally underpinned product development ecosystem or framework at the CSIR. We have experience in helping a diverse range of global companies with product development support, and this positioned us well to support the CSIR in a remote but always present manner, which is key in this ecosystem. And likewise, our internal Siemens Team Center PLM underpinned workflows and the precise digital twin modeling for simulation in NX required for our satellite and space optics in CIMERA Sense prepared us well to implement a lean and focused initial PLM workflow at the CSIR. And we are looking forward to see how the seed that we help to plant at the CSIR will grow into the greater South African landscape and creating the digital golden threads that will weave industry together so that we in a nation can really come together and participate with product development in the future and be relevant in the future. Thanks.
Thank you, Jan. That's a new term that I just learned, digital welding press. Thank you. We have a couple of CSR participants as well, and I'd like Dr. Ajit Gopal, manager of the CSR Center for Robotics and Future Production, to introduce yourself, Ajit, a couple of words.
Yes, thank you, Martin. Good morning to everybody. The CSIR Center for Robotics and Future Production was responsible for using 4IR technology for the design and development of the CPAP ventilator, and then digitally overseeing and coordinating the full lifecycle management, including production, distribution, and support. So I'm looking very forward to the discussion this morning. Thank you.
Thank you. And then I'd like to introduce Rian Kutsia, who's driving the presentation and videos in the background. Rian, if you could just say a few words about yourself.
Hi everybody, name is Jan Kutsia. I'm the manager of the Future Productions Research Group, and the person that was responsible for running this, is responsible for running the project. I think I echo what Johan de Tooy has said, is that the spirit in which this project has done has really changed quite a bit of things for all of us. It showed us what is possible, and I think similar like the Springboks when they came back from the World Cup, is that we can work together and we can achieve a lot more. Thank you, Martin.
Thanks, Rian. And I am Martin Zanne, Executive Manager, CSR Future Production, with a focus on manufacturing. So we'd like to do two things now. The one is to show you all a short video around the project. And then Rian will take us through a presentation, some presentation material to explain the process and what was done. And then we'll open the floor for some questions as soon as we're finished with that. Rian, over to you, if you can spin the video.
The CSIR was contracted to support the National Ventilator Program as part of the South African government's response to the COVID-19 pandemic. The CSIR Lung and Respiratory Flow Enabler, or CSIR Life, is a non-invasive ventilator, rapidly and easily applied as emergency equipment to help patients experiencing respiratory distress. The development had to be completed in a short time frame and ensure that compliance and licensing could be achieved under the South African Health Products Regulatory Authority and guidelines of the World Health Organization. The The system is based on existing continuous positive airway pressure ventilation technologies that supply a pressurized mixture of air and oxygen to the patient through a mask. A mild level of air pressure keeps the airways open and sustains lung pressure. The system consists of a standalone flow generator that is used in conjunction with a breathing circuit comprising hoses, filters, and a mask. A digital development platform was used as part of the product lifecycle design methodology and meant that a product could be transferred to partners in industry who would perform the actual manufacture and assembly and deliver large volumes of units. The systems were tested at Specialist Medical Devices Laboratory at the University of Cape Town and a medical specialist at Charlotte Maxeke Hospital in Johannesburg. Manufacturing of the parts took place in Gauteng and Cape Town. After manufacture, all components are cleaned and dispatched for assembly at Acacia Medical in the Cape Province. Parts are assembled and all units sanitized, labeled, and packaged. The packed products are ready for dispatch to various healthcare facilities across the country.
Thank you, Rian. So Rian, you'll be switching over to the presentation, and I think everyone will agree that amazing pictures that we just saw. Thanks, Rian. Carry on with the presentation.
Okay, thanks, Martin. Sorry, just one thing, just a small technical glitch. Sorry, guys.
While we're waiting, I'll remind the viewers to send in any questions. They'll be relayed to us, so we're open to any conversation, or nearly any conversation.
All right. Just after this video, I just wanted to acknowledge a lot of people that has worked very hard on this. I think first most the Solidarity Fund for funding this initiative, and then Sarah for managing it, and all the government departments that play a role, including SAPRA that did the regulatory stuff. We also had a bunch of industry players that really came to the party with some goodwill, and I'm just mentioning a couple of them: Gabler Medical, Solar Medical, Dalla Vandani, UV Tooling, and we've also worked closely with the University of Cape Town to do the semi-clinical trials, and University of the Free State. And then, of course, Siemens for their donation of the software that made it possible. Acacia, that is probably one of the best medical companies that I came across in South Africa. And then Samira for their support, Quali Health, that is indispensable. And then also people that help us with the quality management systems, the integrated messaging system. So just want to acknowledge these people. What I'm going to present today is not just my own work. This is a work of a group of people, and it's probably more than 30 people that has actively contributed to this project. What I'm going to discuss is basically just the history. Where did the CSR start with digital transformation? A quick overview of the Ventilator project and the timelines. Then just the importance of digital transformation. And currently it's quite a buzzword, but it's something that we need to understand in a business context. And then we're going to go through how it enabled rapid product development, enabled our virtual factory, but also going to talk a little bit about the human element, the people sitting in their pajamas at home, managing supply chains and things like that. Also the current status of the project and the impact. And then we're going to ask the difficult question, or the more important question: how can we replicate this model for the rest of South Africa? But let me just start off. The CSR, as together with Siemens and Rheinmetall, have signed an agreement which is part of the arms deals offset, that the CSR, that Rheinmetall purchase licenses on behalf of the government and give it to the CSR so that we can use those licenses to support the industry. Now, some of those licenses include, it's mostly PLM software, and it includes CAD, CAM, collaboration software, and e-learning access. And there's also some additional things like a lower maintenance cost and things like that that benefited the government as part of the offset deal. Some of the other packages that it includes, it could help with mechanical design, electronic design, software delivery, simulation and testing. And it was really the full suite of digital tools for product development that we acquired the licenses for. And the idea was that we first built internal capabilities so that we ourselves are capable of working with the tools, and then later on can help industry with those tools. So the focus was first internally. We've done that, and we're currently at the stage where we're rolling out the software to industry players and SMMEs to help and support them with their tools through their digital transformation journey. So what the project that when the pandemic happened, one of the projects that we put forward was the development of a ventilator for South Africa. And I can still remember on the 6th of April, it was a Friday afternoon, 4 o'clock, there was a call from proposal from the DTIC, and the full proposal had to be in by the 9th of April at 11 o'clock in the evening. So we literally had a weekend and half a day to basically prepare a proposal for the MVP. The purpose of the MVP, to call it, is to coordinate all the relevant players that were trying to develop ventilators, so that efforts are not duplicated. We were then chosen as one of the teams that were going forward. My understanding was that there was more than 100 teams, and only 4 of them moved forward. The process lines was extremely challenging. I think what you need to keep in mind is it was locked down, so nobody could move anywhere. You had to get special permits. The timescales were extremely tight. There's a lot of regulations that we had to go through. And then, we were looking between 1,000 ventilators and 20,000 ventilators. So whatever you need to put in place had to be scalable from a small scale to a bigger scale. Because of the short timelines, you're going to have to look at concurrent engineering. And, if you look at the Public Financial Management Act, procurement is not as straightforward as in a private sector company. So there was a lot of challenges that we had. The different phases that were identified by the NPP was basically design and prototyping, and then we'll go through a qualification phase to make sure that the design is proper, and then we'll go through industrialization phase where we do a production readiness review, and then basically start with production in a very short time period. I just want to show you an example from one of the presentations that we've done, and you can look at the timelines. From the 21st of May to the 1st of June, that was the qualification of the product development. The industrialization was literally about 12 days that we had to get it up and running, and we had to do production at the same time. So nobody knew when the pandemic or the COVID-19 is going to peak. And the anticipation was that it was going to be mid-September, and we had very little time to get up and running. So this put huge time pressures. It really made us put our thinking hats on to say, how can we do this? Typical medical device companies take 18 months to take a product through to the stage where we wanted to be in 3 months. So we had to put our thinking hats on and say, how can we do this? It seemed like an impossible task. But what we've done is we said, well, we have to run a lot of processes in parallel. It can't be sequential. So we had to look at product development, the usability of the device, the quality management system and the regulatory stuff, as well as the manufacturing already at the design of the product. And also the business model, how are we going to roll it out, how are we going to maintain it. All of this we had to do from day one already. So we had multiple stream and multiple team leaders that were running each one of those channels or paths at the same time. The problem that we also occurred is that sometimes you have to finalize the design before you can continue to production. And what we found ourselves with is that there's multiple iterations that you have to do because of nothing is fixed or finalized. by doing that on a paper system, it's going to be extremely difficult. And that's why we implemented the digital lifecycle management, or some of the old school people call it still product lifecycle management, but the new name is digital lifecycle management. And the software that we managed to get through the offset program helped us tremendously in that. And what it did is we followed the typical V model, where we did the requirements analysis. We then did the product structure or the design or the CAD design in Team Center, which then allows us to pull the M BOM and the E BOM. The M BOM is a manufacturing BOM. The E BOM is basically your procurement BOM. From there on, we could do supplier management and the manufacturing process management, and then a service lifecycle. So we decided that, due to the multiple iterations between the different tracks, and the fact that if you do this by paper, you will probably, create a lot of problems for yourself where things are, delayed and things like that. We decided to do it completely digitally, and via Team Center and the digital lifecycle management. We had to do concurrent engineering. So like I said previously, we had to map out all of the stuff that we need to get, and also the linkages between them, so that we can understand what is influencing what. So any changes that you make on the product will have an impact on the production, will have an impact on the regulatory requirements, and we needed to understand the linkages between them. And that is something that you can't do on paper. That's only something that you can really, through PLM, when you see what is linked to what and what influences what. So that was a big must for us, that we need to implement the digital lifecycle management. The digital lifecycle management also allowed us, once we saw how you can link things together and there's only one truth, one design, it also showed us that, you don't need to be constrained in one physical entity. We could then use that, and we could apply that to multiple entities. And in our case, for example, to be scalable, we started off with CNC manufacturing. It was going to take quite a long time to get the mold going, about 5 weeks, and we had to produce already very fast. So we had 2 tracks of manufacturing. One part was CNC machining, and the other part was injection molding. What we basically could do is we could create a virtual factory, although we're separate entities, and the digital lifecycle management basically allowed us to do that. There were lots of virtual teams, people that we had to consult from Gauteng, Western Cape, Free State, KwaZulu-Natal. As you can imagine, we had to look at the whole supply chain management and had interaction with each one of these teams. So it was quite a big team. It was sometimes difficult to coordinate, and it also resulted in meetings at 7 o'clock, 8 o'clock, 9 o'clock at night to get some of the stuff through. This was all done in lockdown level 5, so minimum physical interactions between people. So what is the importance of digital transformation? I think, as our CEO talked this morning, is basically a convergence of technology between the physical worlds and digital worlds. And what that enables you to do is that you can create digital products, you can simulate it, you can test it before you actually go and develop a physical product. And this is a diagram from Siemens where they talk about the holistical digital enterprise, where you basically create your virtual product, or what they call a digital twin of a product. You do all the specifications in that, and then when you got your real product, you can actually verify it. You can also simulate your production, do some virtual commissioning without any cost or plant layout, and you can verify that, and it then results in real optimized production. So you don't have to set up the plant first and then sort out all the issues. You can probably sort out about 50 or 60% for the issues that you're going to get in a virtual space before you actually have to do it in the physical space. There's currently a lot of buzzwords around digital transformation, 4IR, and things like that. But at the end of the day, it really comes down to how can you add value. So the first thing is, how can you empower your employees, and how can you grow them? How can you upskill them? How can you make sure you know, that you get the best out of them, and they also get the best out of you, you know, from a profit point of view and things like that. So it's all about the empowerment of your employees. It's engaging your customers and improve their experience. You know, when you start having intelligent projects in the market, you get direct feedback from the customers, which will impact your design. So that's quite important. And then also it helps you optimize your operations, and it transforms your product, because your product is not just the thing that you put down at the customer that you utilize and you don't get feedback. It now becomes intelligent product. You can actually create a better environment or a better experience for your customer as well. So at the end of the day, digital transformation really comes around the data flow from your people, from your customers, from your product in the market, and to help you make better decisions. It's not really about, is it IoT, is it a robot, is it not? Those are just tools in the toolbox, but at the end of the day, the end effect must be that you improve your enterprise or make it more productive. So I just want to talk a little bit about the digital transformation or the rapid product development. What the transformation enabled us to do is to develop the product a lot faster. For the people that didn't see the video, this is typically how the product looks like. This is a Venturi ventilator, which basically mixes ambient air with oxygen. On the right-hand side, you will see the actual device. The other important thing that I need to tell is that products don't exist just in a vacuum. They always come with a system. So what we have to take into account is that although we've got control over the product that we develop, we might have little control of the system that surrounds it. And these days, people are looking for systems that are integrated rather than products that are standalone. And we had to get to grips with supply chain management, global supply chain management. At some stages, you know, there were no flights in or out the country. You know, some of the stuff that we imported got bumped off to sea freight and things like that. So there was a lot of challenges that we had to overcome, and most of that actually sit in the system surrounding the product and not necessarily part of the product. Another hurdle that we had to get across was the regulatory compliance. As per Section 21 of the Health Act, we need to apply for a license to be able to produce medical devices in South Africa. And before we could proceed with production, there was quite a bit of a technical dossier that we had to submit to SAHPRA. These are some of the building blocks of those documents that we submitted that was required by SAHPRA. But SAHPRA was also very good to us. They came back to us within a week or two, and then we could proceed. The PLM or the DLM implementation had to be balanced by a number of constraints as well as influencers, things that influence the way that we do it. And that's why digital transformation is not a one-size-fits-all. It's really a personalized journey that your organization needs to take, and even your project or even your product. So it's a very personalized one, guided by your constraints, standards, governance, capability, and technology. You know, we had to look at the impact of ISO 13485, the medical standard, on our implementation. We needed to look at the financial governance, the supplier management, the production ecosystem, the virtual factory that we created, the design tools and the way that we approach it. You know, for the specific product, it was also important to look at that. You know, also IoT strategy, and then we had to go back to the client requirements, and in this stage it was the WHO, as well as some of the SAHPRA and MVP requirements that we had to comply. So these are some of the influencers that influenced us on how did we go through our digital journey. And the first thing that we realize is that you know, you need to put processes in place to be able to meet some of those challenges. And the fact that you put in a process doesn't mean you control it. You're actually just taking the admin away from the typical technical people, and you leave it to the software to do the processes. So you actually follow the processes, and by following the processes, you're actually complying to the regulatory and technical spec that there is. So you can see from requirements, the concept development, detail, prototyping, testing, all of those processes, we had to develop and run them at the same time. That gave us a lot of practical insight on what's workable, what is theoretical, and what's practical implementable. Okay, then what we then found is that this, if you look at the V model, where we use model-based systems engineering, you know, there's a lot of software packages or tools that we can then put into those processes. And you almost form like a tool chain of technologies that you could utilize to get to your digital transformation. All right, and basically, I think the digital lifecycle management or /PLM is really something that, you know, if it wasn't for that, we won't be able to rapidly develop the software, the hardware and the software that we did. Now, this is a slide around our migration. So in the middle, you see Team Center, which is the collaboration tool that Siemens got, and that is considered our digital thread. And what that means is all the data that we generate are stored there. All the final releases of the CADs, software, hardware, everything is basically located there. And on the top side, you see that's a digital space. So everything is digitally done on the top side. And then at the bottom is the physical space. So what we've done is we started with the requirements using model-based systems engineering. We did the concept design at number 2. We then did the actual physical design using CAD. We did some analysis, flow dynamics, as well as strength analysis. We could also use the CAM software to do cutting paths for the tools that we have to make. Then on the physical space, we actually, UV tooling has manufactured the mold for us from those models. We implemented the quality control, the manufacturing execution systems, and then through QualiHealth, we've got access to what's happening with the product actually in the market. And this is how we basically migrated from typical paper-based systems to everything digital, where everything is linked. So if we could basically trace straight from the requirements from the WHO straight to how does it impact it on the MES system, how did it impact it on the CAM, or the tool development, as well as any of the other stuff. And I think that is what is great about the digital transformation, is that everything is connected and it's easily accessible. Just, as part of this project, we had to build a digital twin. Everything doesn't always work as you plan. And to do things by trial and error and keep on making small changes in manufacturing it can be quite costly. So what we did is we simulate the gas flow through the device, as well as some of the strength analysis. And that created a very good digital twin that helped us with the final design of the product. All right, so we've got the product now. Now we need to manufacture it. And that was quite a daunting task. I think, like Martin said, this all had to happen in 3 months. And this was our initial manufacturing and operations plan. We said that in the middle, we've got the digital lifecycle management, which is Team Center. And we're going to plan to pull all the information from the overview, the production, the quality assurance, and the track and trace from Team Center. But we then realized there's one part missing, and that's basically the MES. And we were looking for a MES that is across multiple organizations, that's scalable. And Siemens Ops Center, Siemens showed us that this is something that Ops Center can do. And some of the key requirements that we had is that every part of the virtual factory, we need to get the product data back. We need to get quality assurance data back so that we can make sure whatever they manufacture is of quality. And then we need to compile a device history file. A device history file is where you can trace every part back to the source. And if you've got something in a hospital and something breaks, we can actually go back and tell when it was manufactured, by whom it was manufactured, and who sourced what parts. And that's very important for medical devices. So we looked at the manufacturing execution system that Siemens offered, and we decided that that's something that's scalable across multiple organizations. Some of the base functionalities of this is physical model management. So we could digitally design our assembly lines. We can take that process model and do a couple of what-if scenarios. We can get a product work in progress. The traceability was there, and it also created electronic work instructions for us that we could just print out. And then, of course, the important part is the electronic device history file. That allowed us to go paperless. We haven't achieved 100% paperless, but we're getting there. It's a process. It's not something that you just switch over to. And the coordination optimization of orders materials, it's getting better. I'm not going to lie. I think sometimes, you know, I think Peter Brearley, one of the colleagues that talked, he always say that production is messy. But I can tell you that Ops Center helps to make it a lot less messy. When we spoke to Siemens, they came to the party, and what they proposed is that we look at Ops Center Execution Core Intelligence module, where we can do work in progress tracking, the device history file, dispatch management, smart scanning, and you can see a lot of the workflow routers when you scrap stuff, electronic signatures. So there's a lot of modules that they could implement. They also had about 3 weeks you know, to make this decision and start with the implementation of getting this go. And that was quite an achievement from Siemens to be able to do that for us in such a short time. So these are all the theories and things that or all the thinking that we had around it. The problem is, you have to go and implement that on a line. And that sometimes is quite a different thing, because things keep on changing. You're baselining certain things and you're making changes. So one of the important things about Ops Center for us is that it's zero code modeling. So you can actually do the modeling without doing any programming and make changes on the fly. And that was very important for us because we were designing and doing production and optimizing the production at the same time. And there's frequent changes that happens almost on a weekly basis that it needs to be seamless and it needs to be easy. If you had to run a paper system, it would probably be impossible to do it at such short time spaces. This is just a typical example of the CPAP or the ventilator air O2 assembly line. So you can see it's basically drag and drop, and you can then model the whole process or the assembly line that's happening basically from the raw materials incoming to the end. On a practical level, we had employed about 8 students that were at the factory, each one with a tablet, and they monitor as the assembly progresses. And in South Africa, we're looking at people that are out of jobs, and and part of digital transformation is also automation. What was important for us is that this solution help us to do human integrated automation. So we center the human in the middle, which is typically the students that were here, and we equip them with technology to help the automation. So it's also called human-centered automation, and that's something that I think a lot of factories could really make use of. Still keeping, the technology, still be able to digitize it, but to have the human in the loop. We use standard Android tablets, and we connected with these tablets from Cape Town to our server in Pretoria so that they could capture the real-time production that's happening. Just some of the assembly lines at Acacia. The interesting thing here is, and Peter can maybe talk about it, but most of the factory workers are women. And it was interesting to see, the speed and the pace at which they are working. So that was also something that was quite good for us. Just some more pictures around some of the assembly. This is the injection molding where they basically put on the covers of the injection molding part. I also just want to talk a little bit about the digital transformation around the human element, and what does that to the people. You know, on the product side, we've got Team Center and the PLM that helps us. On the process side, we've got Ops Center and the MES. But there was also a bunch of tools that we utilize, from Google Drive right through to Rainbow and Teams and things like that. So one of the key things is you need to enable your staff or the people working on this with the right tools so that they can work any place, anywhere. So that is quite key. Maybe just some notes. We only had 2 factory visits during that whole 3-4 months when we went to a Kaiser down there. We probably had over 1,000 teleconferences. People worked about 60 to 80 hours a week. So it's very important, you know, to keep your people motivated. And, you know, when things goes wrong, and they did go wrong, how do you motivate and pick them up? It's sometimes easier physically, a lot more difficult to do that remotely. So there needs to be a good amount of trust between, you know, between people. A large number of factors were out of our control. Like I talked about the logistics. Sometimes countries just closed and they decide not to export or put anything on a ship. We had a lot of regulatory compliance issues, but, you know, people work through that. And it's quite a challenge to make sure that people that are working remotely are happy and can actually continue on, you know, with the actual work. I'm running out of time. Just the current status and impact of the project. We distributed to date about 7,000 units to about 60, 70 hospitals across South Africa. The rest, we're waiting for allocation from the DOH. So we've already manufactured about 10,000 of those. And we're busy with the production of another 8,000 on top of that. These are just some of the hospitals that we send it to, and the amounts that we send to those hospitals, to just get an idea that it's basically all over South Africa at this stage. Then I just want to say one of the key things for us is the support for the ventilators. And if you look at digital lifecycle management, a lot of people forgets about the product in the market and the feedback that they get from there. So the role that Quali Health is playing for us is very important. We had to create a support system for the product in the market, and we had to monitor, you know, how that actually goes with our product so that we can make some design changes. So they provided medical support where they have medical physicians that are helping other physicians, but then also technical support, and they implemented a WhatsApp help desk that is very easily accessible for any nurse or any doctor in rural or in urban areas. All right, we also just not create the product, but we also did localization. It became very apparent that some of the stuff we won't be able to import it. There were holds on some of the PEEP valves and things like that, and the ones that we could get were so expensive. And we also embarked on, you know, we helped and support 3 companies in localization of some of their devices. The one was from the Central University of Technology, Gary Boyens and his group. They developed a viral filter for us that you can open up and you can take the viral insert out and replace. That is a fraction of the cost of what a normal one cost. And they're currently locally producing that, and we were part of the process to get that going. The same with Solar Medical, that makes a lot of connectors and T-pieces and things for us. They become in very short supply globally, and we had no other choice to basically, you know, start with the production of that locally. And then also Gabler Medical Group that we supported and helped to get their variable PEEP valves and PEEP valves up and going. So I think the benefit or the impact of this project was not just there's a ventilator to save patients, but we also started with the localization of the industry, which is very important. Currently, we're importing close to 10 billion rands of medical equipment on a yearly basis and only exporting about 1 billion. So we need to change that around. So the question is, how can this be replicated to South Africa? We've shown that it's working. The digital transformation is you know, what we've implemented is working. We could get a product out fast. So how do we replicate this to the rest of South Africa? Now, the digital product development approach that we followed, there's some benefits of it. It can be scalable. So it's easily scalable with the tools that we've got. You can scale it into one company or multiple companies or even a sector if you want to do that. You can pivot this to any industry. We've done it in medical device industry, which is heavily regulated, which means you can probably pivot it into any of the other industries. By design inclusive, we've got one truth out there, and multiple people can collaborate on that one design. And we open that up, and you've got proper control around that. We've got standard workflows that are there to approach to get to standardization. And the collaboration on the platform makes it very easy for anybody, even across the world, to be able to collaborate. So this arrows that you see here is just a typical tool chain that we utilize. As you will see, most of them is Siemens products because we had the software. But I think the process to be able to get to a digital twin and to be able to digitally transform is the important part. And what you see here is just the tools in the toolbox that we can help and provide for your digital transformation. Last slide. The CSR is really trying to support industry. I think, as our chairman has said, that we are there to support the industry, but we're also not going to do this alone. You know, we're busy creating an expert ecosystem consisting of universities, science councils, international experts, industry experts, and try to collaborate to get the best possible solution for the industry out there. And we basically got 5 main areas where we want to help the industry with. The one is we want to prepare them for the digital transformation, and that's where one of my colleagues will talk about the learning factory, smart factory a little bit later. But also we do 4IR readiness assessments to see where are you currently and where do you need to go, so we can help you prepare. We can help you to innovate, where we look at product development and localization of technologies. We can also help you with competitiveness. Make sure that your current operations is perhaps, you know, lower cost, higher quality. And we can also provide support regarding certification, regulatory compliance, benchmarking, and even help you with some rapid prototyping. And then the key areas for the 4IR, where most of the growth is lying, is creating digital twins, expert system, decision support systems, and then obviously help you with the digitization. And I think, like I said, you know, we're not just doing it alone. We have a whole ecosystem of expertise, and some of these partners, you know, was part of this ventilator project that we did. So what we'll do is, on any future project, we'll also involve our partners where appropriate. All right, Martin, that's all from my side.
Thank you, Rian. Wow, that's quite a marathon in many respects. We've gathered a couple of questions from the audience, and I'm just going to package them all together in a brief statement. And then I'd like to give our partners who are present today on the call and on the video a chance to say a few words to that. The main tendency or tenor of the questions has been, can be grouped into, this is definitely a revolution. How can we harness this to bring the capability of South Africa to bear better? So we have so much capability in so many small and large companies across South Africa. What do we do, and how do we do it to now move from one project to many projects? And what, in a nutshell, very short sentence from each of you, what was your biggest learning experience in the process? So what would you recommend, and what would you do better? So if I can maybe start off with Johan, from a software, overall software systems approach and a systematic approach, if you could say a few words to that, to this brand new vision and brand new approach, which has now been executed completely in one complete process. So we have probably one of the best case studies. Yeah, Johan, in a few sentences, about a minute.
Yes, thanks, Martin. Just a clarification, my pronunciation was probably a bit unclear. What I said earlier was there's a digital golden thread. So that's weaving it all together. And that's actually relevant to the answer here now as well, that if you have this baseline that you trust and you can participate with your skill set coming in and going out, and that process is defined without having to understand the complexity of the whole process. Every SME can participate. If you want to work with a big company, OEMs, it's easy to participate, and that's the one success. And just another insight from my side, and it might be considered negative, but in a way, this kick, we've got a kick from the back now to expedite this remote collaboration and thinking new. And in a way, this negative of COVID gave us as industry, and particularly CSR and these partnerships, a confidence boost that we can do it, and we must just use this energy. That's my 1 minute summary.
Thanks, Johan. Kobus, what would you say?
I think, Martin, what is important, as a technology provider, we see all these case studies worldwide of how people are doing all of these wonderful things. And what is great for me in this project is that we managed to do it properly in South Africa. And we showed that it can be done with our resources, with our people. So, the important thing with a lot of these technologies is the capability you've established in this project. And I think we need to leverage that. We need to leverage that into SMEs, into other companies, so that this capability can be rolled out to really make us competitive on the world market.
Well said. Thanks, Kobus. Peter, you're in the middle, in the thick of things. You had to bear the brunt of the rollout, or the putting everything together into boxes, making sure the final quality check was there, and then getting it onto the road. So, what are your thoughts?
Yeah, it's often been said that plans don't survive the first shot on the battlefield, or words to that effect. And to me, probably the best thing about this whole project has been the environment of trust in which we've all operated. That there's been utter faith, effectively, from everybody, that everybody is doing their best to get this thing done, and get it done in the best possible way, as quickly as possible, understanding that the ultimate aim is to provide support for people who are dying literally out there in the hospitals. So the sense that I have is there's been a kind of no blame environment. And if I was to say a couple of things really about, and to echo Johan's comment earlier, that if there have been any positives to take out of this wretched COVID thing, it has been that it appears that the environment has healed quite quickly. And secondly, that it's probably woken up our government and the rest of us to the fact that we actually need to have manufacturing in our country. We cannot rely on imported stuff, and we actually have the capabilities and the attitude to in fact do things in this country for our country. And we need to get back to that, because apart from anything else, it creates jobs. So I think for me, if I could take a word away or put a word into everybody else's heads, it is about collaboration. Effectively, Gabler Medical and our company are direct competitors in the marketplace, but we've collaborated. We've worked together, we've helped each other for a common good. And I think that for me is a real win. So that's my takeaway from the thing. We can do it, and we should.
Thank you. Those are very wise words. I'd like to, as a last speaker, give Tabi Singh a quick moment to... You're sitting at the back end of the process.
I was about to say, so my job, I'm joining this thing on the tail end, because our job starts now. And what's important for us is make sure that we give as much, it's not just support, because support just puts it in a different frame, it's data. giving back the data. And we see our role as data mainly in user experience, but also if there can be some data that we can give back in terms of manufacturing quality or variation in manufacturing quality, based on the queries that come in, that I think could be valuable for the project and other projects going forward. Data in terms of if there's variation in designated user. So example, is it different when a nurse or a doctor uses it in terms of understanding the product and just the experience of the product? That we think is data that could be quite useful. Down the line, as we use it, we'll be able to see if there's any data that can come back from medical outcomes versus conventional ventilators. And lastly, as we go along and as we get approval in non-COVID patients down the line, we'll be able to just see if the experience is different in COVID versus non-COVID. But also just set up our environment to let the data speak for itself and to get some insights come in and patterns that we might not necessarily be thinking about right now that could make future projects easier and better.
Thank you. Thank you. Okay, on that note, thank you very much. Thank you to you all. Thank you to the listeners, viewers. Thank you to the participants, and from the CSR team, Dr. Ajit Gopal, Rian Kutsia, myself, and the people behind the scenes and in the conference rooms doing the videos. Thank you very much. Have a good day to you all.
Thank you.
Thank you.
digital transformation for the fourth industrial revolution. It's based on a facility we're developing, where we're looking at innovative technologies to address the skills gap for digital. Good day. My name is Shanil Devraj. I'm an engineer at the Center for Robotics and Future Production at the CSIR. My presentation today is titled Learning Factory, Growing into Digital Transformation for the Fourth Industrial Revolution. It's based on a facility we're developing, where we're looking at innovative technologies to address the skills gap for digital transformation. I'll begin with the modern trends that we face in our society. The first is that with the fact that we live high-paced lifestyles. This places a strain on performing everyday tasks. We have to balance work, managing our households, and our health. A recent study at the University of Oxford showed that South African employees work amongst the longest hours in the world. Furthermore, a South African study showed that last year alone, we spent a significant amount of time in traffic. The time lost to congestion in Johannesburg for an individual on average was estimated at 74 hours. In Pretoria, it's estimated at 65 hours. And in Cape Town, a whopping 124 hours was lost due to people spending time in traffic. The second trend that we notice is that globalization of markets makes more products available and accessible to everyone, even in remote locations.